Hello everyone and welcome to the tutorial for the A4 Vampire Attack assignment. Grade 8 assignment here. We're looking at the title page right now, which you clearly know how to find if you found the tutorials. Just a reminder that you can do Control minus to zoom out and Control plus to zoom in. That's going to be something you really need to know for this assignment. You want to be zoomed out on the title page so you can see the 5 blue arrows that are pointing at the 5 tabs along the bottom. These are the sections that need to be completed before you hand an assignment in. So we're on the home page right now tab. We're going to switch over to the vampire attack, and part 1 of the tutorial will be all about how to get the vampire attack finished. So in this scenario, we have a crazy friend Bob who comes to you in a panic and claims, "We're all doomed. Didn't you hear? There is going to be a vampire outbreak." You try to explain to Bob that vampires can't exist, but he insists you are wrong. He claims the first vampire is 400 years old. You tell Bob, "I can prove to you that vampires can't exist using Google Sheets. Show your proof below. There's a lot at stake." So we're going to try to do a mathematical proof by contradiction, which means we're going to humor our friend Bob and say, you know what, let's pretend that there is one vampire. Well, what's going to happen if there is one vampire over time? If we can prove that something, unbelievable happens because of that one vampire, then maybe we can help convince our friend Bob that it can't be true that there's one vampire. And that's what a proof by contradiction is. You kind of say, okay, let's say it were true. What would happen? We also have a couple other things. So the one vampire at the start, all vampires need to feed once a week. This is kind of the premise of our proof. We don't know what's true and what's not. Vampires don't really exist, so we're kind of making up the rules here. And number 3, the fed-on victim then becomes a vampire. So if you're a human and you're bitten by a vampire, you also become a vampire. That is in some vampire lore, but not all of it. So we're going to go with that to make this proof happen. Review from grade 7 IT would tell us that these letters across the top are columns and they're vertical. And we've got these numbers across the side, which are horizontal rows. And where something intersects, it forms a cell. This is cell A8, for example, where the word week is. So I'm going to take you through just the first part of this assignment here in tutorial number 1. And then the future tutorials will do the Vamps Be Gone tab, the Your Turn, and so on. Okay, so here at the beginning of time for vampires in cell A9, we have week 0. That is the beginning of time. Nobody's been bitten yet, and there is one lonely vampire roaming the planet. We don't know how the vampire got here. Doesn't matter for the proof. We're just humoring our friend Bob for the most part. Okay, the human population is around 7.8 billion at the time that I made this assignment. I think it's a little bit higher now, but that will be fine for the sake of this proof. In week 1, a week passes, the vampire gets hungry. That means they bite one person. Well, that one person becomes a vampire, so we have the one new vampire and the one old vampire, which makes 2 total vampires. In week 2, we now have 2 total vampires who are biting one person each, which equals 2. And the 2 new vampires and the 2 old ones make 4 total vampires. 4 bite 4, and now we have 8. 8 bite 8, and now we have 16. You can probably already see a pattern happening. So if you plot this a little bit further, we would have week 5 where there's 16 new people bitten and 32 altogether. In week 6, we would have 32 people bitten and we would have 64. In week 7, we would have 64 and 128. In week 8, we'd have 128 and 256. In week 9, we'd have 256 and 512. And after 10 weeks, we've got 512 people bitten and 1,024 total vampires by the end of the week. Now, we're not done our proof at this point because, you know what, vampires are good at hiding. It's very possible that they could hide since they only come out at night. We're going to have to go further than just finding out that there is 1,000 vampires. So we're actually going to plot this to 35 weeks, which is going all the way down to row 44. We don't want to do all of that math, though, because these numbers are going to get very big. So let's make the computer do some of the math for us. Remember, computers are very good calculators. They're not good at knowing what to do, but they're good when you tell them the right thing to do. So here in cell A20, I'm going to start with an equal sign. And I'm trying to look at the pattern here in column A. It clearly goes up by 1. We want to actually take the thing before it and add 1 to it. So I'm going to click on A19 so the computer knows to take the thing before it. And I'm going to say plus 1. Okay? So the whole formula there is equal sign A19 plus 1. I can press enter. I get the number 11. Well, the super handy part now is I can take that formula in cell A20 and I can grab the little crosshair, the little black crosshair that appears in the bottom right hand corner, and I can just pull it down, and that'll apply that formula to the rest of the cells where it takes the thing before it and it adds 1 to it. In column B, we have a different pattern happening. That's why our numbers are going to get so much bigger in column B. But we have a pattern of doubling, you might notice. So again, if we say equal sign and take the thing before it and multiply it, which is shift 8 the asterisk by 2, that is a way that we can double something. So equal sign B19 times 2, enter. Okay, ask yourself, does this make sense that 1,024 people are bitten in week 11? It does, because there was that many vampires the week before. So let's take the crosshair and pull it down to the bottom. Wow, okay. So we have 17.2 billion people bitten at the end of week 35. 35 weeks is not even a year. So in less than a year, there's 17.2 billion people bitten by vampires. We kind of already have our proof, because there's no way that that could happen considering that the world population is 7.8 billion. The vampires would have run out of food. They would have started to die off after not having a food supply. So we're going to go finish the proof anyways, though. So here we're going to say equal sign. The pattern in column C is the same. So take the thing before it and multiply it by 2. It is doubling. And there you go. If we pull this all the way down, you will see that if food supply wasn't a problem for vampires, there would be 34 billion vampires after 35 weeks. This is what you call exponential growth, when numbers start pretty small and then they take off. Now, to really understand exponential growth, we're going to graph it to see what that looks like, and we're going to do that in just 1 second. First, the human population, though. So what's happening here in our human population? Basically, we're taking whatever the population was, and we are going to subtract the number of people bitten that week. So equal sign, the thing above it, which is the old population, minus the number of people bitten. Enter. Okay. Don't always take these suggested autofills. This one is not accurate. I'm going to reject it. And I'm going to take the formula that I did instead, and I'm going to pull this down to the bottom to match it up. Oh boy, bad time for humanity here, as we have a negative population. A negative population doesn't make sense. So somewhere in here, we actually ran out of humans on the planet. And so that means also that somewhere around here, vampires would have a problem too and start to die off. But we're not going to adjust those numbers. We're just interested in looking at how this is happening. And you can see, like, look at the steady population all throughout here. And then all of a sudden, once the numbers get big enough, things take a turn for the worse pretty quickly. Okay, last part of this tutorial is how to make the graph. We want a line graph because that shows change over time, and that's where we're going to stop this tutorial. So here we go. We're going to select our data, not with the crosshair, but with the blue, with the black arrow, which is going to make the text kind of selected in blue like that. And now we're looking for the insert chart button up here. So once we have our data selected, we can say insert chart. There we go. This is our graph of exponential growth. And we can see right here that it already picked a line chart. But if it didn't, if it picked something else, like let's say a bar chart or something, or a column chart, any of these things, you can see how quick the computer is at switching back and forth between chart types. Then just switch it back to a line, because the line graph again shows the change over time, and that's what we're going to be most interested in. You can see that it looks like there's some kind of mistake because the red line is the total number of vampires, and it looks like it's 0 all throughout here. But it's just because the scale of this graph. This is going up by 20 billion at a time. So even after week 10, when we knew there was 1,000 vampires, well, 1,000 compared to 20 billion is going to look like nothing. But if you could zoom in enough on that line, you would see that it's not actually nothing, that it's not touching the line. So there we go. This is called exponential growth, when something goes up like that very quickly at the end. Looks like nothing, 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 and then kind of an explosion of results. And the opposite for humans, as nothing's happening, it looks like, and then rapid deceleration happens right around the same time that the vampires take off. And that's not by accident, obviously. Here you can kind of see where we would have roughly the same amount of vampires as humans. And the only thing we have to do in this assignment to finish this up is give it a better title and label the axes. This is your x-axis, this is your y-axis. So if we go into customize, I would like you to give, under chart title, give it something better than this. Something that's going to describe better what we're looking at in this chart. Also for the x-axis, the horizontal, it already says week. And that is kind of what we're looking at here, so that might be fine. Under the vertical title, which is here, the vertical axis, it doesn't say anything. So think about something that might describe what we're looking at here. Keep in mind that it's representing both vampires and human population, so maybe just the word population would be good to have on that side. Okay, so that pretty much wraps up the end of tutorial number 1 of how to do the Vampire Attack tab. Be back soon to explain the Vamps Be Gone tab. Thanks for listening. Hope that helped. Bye-bye.